In Chapter 7, Section 4, we're going to take what we've learned about solving quadratic equations and look at some equations like these below, which are not quadratic equations, but considered to be equations in quadratic form, or as I like to say, in the form of a quadratic. So if we look at x squared minus 5x minus 6 equals 0, definitely a quadratic equation. Here we've got parentheses 3x minus 2 quantity squared minus 5 times in parentheses 3x minus 2 minus 6 equals 0, or the quantity 1 over 2x squared minus 5 times the quantity 1 over 2x minus 6 equals 0. And all of these things are not exactly quadratic equations. Look at x minus 5 times the square root of x minus 6 equals 0, or x to the fourth minus 5x squared minus 6 equals 0, or x to the negative second power minus 5 to the negative first power minus 6 equals 0. And I deliberately chose the same coefficients here and same constants so we'd see some similarities. They are not quadratic equations, but they are in the form of a quadratic. What does it mean to be in the form of a quadratic? Well, let's take a look. I would say that we have at most 3 terms. Now I know when we take this binomial and square it, that'll change things. But in its original form, we've got 1, 2, 3 terms. In its original form, we have 1, 2, 3 terms. And all of these, we have at most 3 terms. And the variable occurs at most twice, or variable expression in this case. So we have the variable expression occurring twice, this variable occurring at twice, this variable occurring twice, this variable expression occurring twice, at most twice. And then for all of these, if we look at the smaller of the 2 variables and square it, we would get the larger variable. So x to the first, we square it, we get x squared. Think of the parentheses as the variable expression, that's the smaller one. Square it, you get the larger one. Same thing here, the parentheses and square it, we get the larger one. Square root of x, when you square it, we get x. X squared, you square it, you get x to the fourth. X to the negative first power, you square it, you get x to the negative 2. So if all of these things are true, then we can solve these equations, even though they're not quadratic equations, using any of the methods we have learned to solve a quadratic equation. What are those methods? Well, we've had factoring, completing the square, or the quadratic formula. Those are the methods we've applied to solving quadratic equations, and we can apply those methods to solving equations that are in the form of a quadratic. So as we look at example 1, it's in the form of a quadratic. So let's factor this one. And think of this, might be easier for some of you if we wrote this as p squared minus 5p minus 6. In that case, p squared minus 5p minus 6 is going to factor as p plus something, p minus something. We're looking for factors of 6 that subtract to give us 5, so obviously that's 1 and 6. The 5 is negative, so the 6 goes with the negative sign. And it's not the p, but the parentheses, 3x minus 2 minus 6 times 3x minus 2 plus 1. So for some of you, you might want to do a substitution. Some of you, this might be a little complicated. You might just want to start out with p squared minus 5p minus 6, factor that, and then when you're done, replace the p with the 3x minus 2. But in this case, now, we're going to look for our 2 solutions. So we're going to set each factor equal to 0 according to the zero product property and solve. So the 3x minus 2 minus 6 is 3x minus 8. That's equal to 0. 3x minus 2 plus 1 is 3x minus 1. That's equal to 0. Add 8 to both sides on the left. Add 1 to both sides of the equation on the right. For both of those equations, divide everything by 3. And we get our 2 solutions, 8/3 or 1/3. So even though it was not a quadratic equation, it was in the form of a quadratic, and we used factoring method to solve and find our 2 solutions. So if we're solving this next equation, we're going to continue with the same kind of pattern. And let's take a look. We're going to use the quadratic formula in this case. And so in this case, we'll think of the parentheses squared. So p squared minus 5 times p minus 6 equals 0. So the coefficient of the squared term is 1. Coefficient of the linear term, so to speak, is negative 5. and c is negative 6. Substitute those numbers into the quadratic formula, which we were accustomed to doing, and simplify. Negative 5 quantity squared is 25, and then negative 4 times 1 times negative 6 is positive 24, and in the denominator 2 times 1 is 2. Now notice what's on the left side of the equal sign here. We're not solving for x anymore because this is not a quadratic equation. It's an equation in the form. And so whatever this smaller variable is, that's what needs to go over here on the left side of the equal sign. It's 1 over 2x. If we were doing this in the previous problem, it was whatever would be in the parentheses would be over here as well. So let's keep simplifying the right side. 25 plus 24 is 49. Square root of 49 is 7. We have two cases here. We have 5 plus 7 over 2, 5 minus 7 over 2. But they are not equal to x. They're equal to 1 over 2x. And so to continue simplifying those, 5 plus 7 is 12. 5 minus 7 is negative 2. 12 divided by 2 is 6. Negative 2 divided by 2 is negative 1. But that's not x. That's 1 over 2x. So let's take the reciprocal of both sides of both equations, and that'll give me 2x over 1 is 1 over 6. 2x over 1 equals the reciprocal of negative 1 is also negative 1. And now simplified, divide both sides of this equation on the left by 2, and a half of 1/6 is 1/12. And on this equation on the right, divide by 2, and we get negative 1/2. That's what x is equal to. So it's important as you're doing the quadratic formula not to leave the left side of the equal sign blank, not to think of it as x. It's whatever that smallest variable is. All right, let's just take a look at our next example, example 3, see what we can do here. And again, if we use the quadratic formula, a is 3, b is 4, c is negative 2. And it's possible this could be factored. If it is, feel free to do so. I don't know offhand. If so, it'd be a trial and error. But let's go ahead with the quadratic formula, because I want to emphasize that the left side of the equal sign is not x. It's whatever this smallest variable is. And in example 3, that's the square root of x. All right, let's fill in a, b, and c on the right side of the quadratic formula. Start simplifying that. 4 squared is 16. Negative 4 times 3 times negative 2 is positive 24. 16 and 24 is 40. And simplifying that, that's 2 square roots of 10. But that's not x. And we still have a greatest common factor of 2 in the numerator that we can factor out. So my two almost but not quite answers are negative 2 plus the square root of 10 over 3 and negative 2 minus the 10 square root of 3. But that is not x. That's equal to the smallest variable, which I write it down just to remind me what I am solving for, and that's the square root of x. All right, well, in this particular situation, what we want to do is we want to find an approximate value rather than an exact value. So the square root of 10 is approximately 3.2. Let's continue on simplifying. Negative 2 plus 3.2 is 1.2. 1.2 divided by 3 is approximately 0.4. Over here on this side, negative 2 minus 3.2 is negative 5.2 divided by 3 is approximately negative 1.7. And to find out what x is, we're going to square both sides of the equation and find out that x can be 0.16 or x could be 2.89. Now what's with all the red ink lined out? Well, remember that when you square both sides of an equation, you must check your answers in the original equation to see if it works or if it doesn't. And what I did in this particular one is I didn't write it out for us, but I checked the 2.89. It does not work. The 0.16 does work. Remember, when we square both sides of an equation, we can get an extraneous root. Let's look back at our original equation. Because we had x to the first power, so the fundamental theorem of algebra says we were looking for one answer. We ended up getting two answers, so we must check them to see if there's an extraneous root. The 2.89 did not work. But we've done that in a previous exercise, so I'm not emphasizing the checking the work right now. Alright, let's look at another equation. This one is not quadratic. In fact, it's x to the fourth, so we're looking for 4 solutions. 4 solutions. Very important that we find all 4. Now, why not factor? Because this is 1, so that would be FOIL backwards. And the signs are one of each, so we're looking for factors of 18 that subtract to give us 7. 9 and 2 will fill the bill there. 9 goes with the plus sign because we want a positive 7. So we've got our 2 factors. Of course, there's many ways of factoring x to the fourth. Could be x to the first times x to the third. But in foiling, the only way to go outsides and insides and get x squared as the middle term is if we multiply x to the fourth as x squared times x squared. Alright, zero product property says set each factor equal to 0 and then solve. So on the left, x squared equals negative 9. On the right, x squared equals 2. Square root both of those equations. And remember that the square root of x squared is the absolute value of x. The square root of negative 9 is 3i. Square root of 2 can't be simplified. And the absolute value equals something. Our shortcut for the positive 0 and negative case are to put plus or minus signs in front of it, which is very important in this situation, that we have 4 answers, as we noted, for the fundamental theorem of algebra. So our 4 answers are positive 3i, negative 3i, positive the square root of 2, and negative the square root of 2. And that's our look at solving equations in the form of a quadratic. I know we only did factoring and the quadratic formula. You could do completing the square, but I find that most students find that unpleasant, so we'll just leave it with these 2 methods.